Welcome to the ocean. As beautiful as it is mysterious, and the stats are well known by now. Around 71% of the Earth's surface is covered by water, and yet 80% of the ocean is still said to be unexplored. And while there has been a greater push in recent years to increase our knowledge, the seas still rank as one of the greatest unknowns on our planet. It's perhaps little wonder then that so many legends and conspiracies surround what could be lurking in the deep. From the Kraken to the Loch Ness Monster, we humans have continually cooked up stories of monstrous beings that might be hiding out of sight. All while we've gorged on tales of great white sharks, killer whales, and other ocean hunters with an unabating interest. However, while not every ocean predator is quite so Hollywood blockbuster in its approach, scientists believe that they may have just discovered one that really could save the world. The single-cell microbe known as Prorocentrum cf. Balticum, or PCF Balticum, could become vital in our efforts to lower carbon levels on Earth. It's what's known as a mixotroph, which broadly means that it can make use of multiple sources and methods for energy generation. With PCF Balticum specifically, it uses photosynthesis, much like the more widely understood phytoplankton does, but it also eats other microbes. This means that it could potentially survive in ocean regions that are more lacking the conditions needed for photosynthesis, and is potentially, then, a stronger, hardier, and more versatile organism than phytoplankton. But why does that matter? For years, we've realized how phytoplankton has been leading the line for the carbon cycle on Earth, capturing carbon on the ocean's surface and ridding us of it by transporting it to deep water. With mixotrophic organisms, however, the carbon turnover rate is essentially much higher. PCF Balticum has been found to ensnare other microbes in a kind of mucus-like product before feeding on them, and then discarding them again to the deep water. In short, this means that more carbon is being processed and contributed to the carbon cycle. More of what we want less of on the surface is sinking to the floor. The bacteria were discovered off the coast of Australia by a team at the University of Technology, Sydney, UTS. The study was published in Nature Communications in March 2022, and while it remains early to draw major conclusions from the find, there is a sense of excitement and optimism. According to an accompanying article published by UTS, the newly discovered microbe could sequester carbon naturally, even as oceans warm and become more acidic. The study lead, Dr. Michaela Larson, has explained that PCF Balticum could occupy parts of the ocean devoid of dissolved nutrients and therefore unsuitable for most phytoplankton. Meanwhile, Professor Martina Doblin, another author on the study, has suggested that there is perhaps greater potential for the ocean to capture more carbon naturally through this process. Dr. Larson further compares the mixotrophic organism to something like a Venus flytrap on the ground. Not only does a Venus flytrap photosynthesize normally, but in catching insects, it has another and seemingly effective means of turning over carbon. A mixotroph has the potential to do so much more of the heavy lifting then, which is something we could really need going forwards. The team at UTS refer to a widely cited 2018 report by the National Academies of Sciences, Engineering, and Medicine in the US, which claims that to stabilize carbon levels, we'll need to be removing around 10 gigatons of CO2 by the year 2050. A new breed of microscopic predator could certainly help toward that goal. It's not as though PCF Balticum is our only hope, however, and as humans are prone to do, we have turned our technological minds to the problem too. An increasingly prominent phrase in future tech is direct air capture, or DAC. In short, this is a proposed artificial method for drawing CO2 out of the air. Advocates generally envision a future time when the planet is dotted with DAC plants. These plants could well be vast and sprawling depots that will essentially suck in the surrounding air, filter the CO2 out of it, potentially reuse that CO2 or else bury it, and re-release the filtered, clean air back out into the atmosphere. The theory works, but there are various potential problems. Critics claim that DAC plants could prove far too expensive, or could even be counterproductive due to the energy required to make them work. While estimates vary, it's thought that we could need tens of thousands of working DAC centers before we could even begin to break even with carbon. And that's a future that remains difficult for investors or governments to commit to, seeing as the technology is still within its very early stages. Supporters of DAC, however, are clear that it could yet be our best hope. The argument being that a DAC plant removes at least some of the responsibility from the individual. It's a mass-scale technology that requires less in terms of everyone changing their behavior. And as carbon emissions are reportedly still rising, despite the various warnings in recent years that society needs to change, perhaps this kind of strong-arm approach is really what's required. On the other hand, might there yet be a balance to be struck? And could the natural world again play a significant role? Many hope so, and it's perhaps one reason why breakthroughs such as that made by the University of Technology, Sydney could prove so important in the long run. While the unknown prospect of air-cleaning DAC factories looming on the horizon of our future world can perhaps feel a little ominous or daunting, the notion of introducing more natural carbon cleaners into the environment seems remarkably simple. UTS's Professor Doblin addressed the possibility for large-scale cultivation of PCF Balticum in the same UTS article following her study's release, explaining that there's more work to be done. We need to find out more about this particular microbe, and perhaps there are more mixotrophic organisms out there too, waiting to be discovered. It's certainly another reason why exploring more of the ocean might be a good idea. At this early stage, however, Doblin says that this could be a game changer in the way we think about carbon and the way it moves around in the marine environment. When it comes to fighting climate change, any improvement is good news. The microbe discovered by UTS has already been widely described as a secret weapon, but time will tell how effective it can be. For now, it's one potential solution in a tentatively growing arsenal of technologies and natural remedies that might prove crucial. But the chief concern is still whether we're moving fast enough. Whether it's direct air capture or natural mixotrophic microbes, our inventions and discoveries need to be converted into real-world climate change answers, and quickly. So, what's your verdict? Could this microscopic organism really solve all our problems? Should we be introducing more of it into the ocean? Or is DAC a better option? Or maybe a combination of the two? There's no doubt that tech-based answers offer plenty in terms of innovation, but perhaps the natural world could still be our most revealing and reliable source of inspiration when it comes to getting back to where we want to be. Because that's how this tiny ocean predator could solve Earth's carbon